Hi everyone. Okay, it's blurring, it's focusing. We're on step-by-step 3. These take about 15 minutes to do. They're free response questions. Are we ready? Here we go. Here we go. Find the limit. Anytime you have x approaching infinity, that needs to be attached to a flashcard in your head. So anytime you have a limit as x approaches infinity, what's on the other side of that memorization flashcard? What does that mean? Anyone know what this means? It means something from pre-calculus, something you learned before coming here. All right, this means a horizontal asymptote. Does that ring a bell? Okay, if you know it, you can get the right answer. If you don't know that, you need to study your flashcards. So what we're telling us to do, it's telling us to take f and multiply it by g, and then find the horizontal asymptote of that. So f is 2 over x squared. We're going to multiply that by x squared minus 6, and that's over 1, which means I'm going to go fast. So if it feels like I'm going fast, I am, because these take 15 minutes just to do, but as I start explaining, that kind of extends our time, and we only have 15 minutes on these videos. Okay, is this small over big, same over same, or big over small? Same over same. So the answer is the ratio of leading coefficients, which is 2. Final answer. Same over same means the answer is the ratio of leading coefficients. What if it was small over big? 0. Good. And big over small we shouldn't see, but it would be a slant asymptote. Find the derivative of this. Now initially I think, oh, we're going to have to use a product rule, but what if we can simplify it first? So let's figure out what is the f function times the g function. Didn't we already do that in A? So the thing about free response is that you can use a previous work to answer the next question. So we already did f times g. Here times here is this. Yeah? So, well, what do we have now? Is this a product or a quotient? That's going to be a quotient. So it fooled us, fooled me. I thought we were going to use a product rule, but really we're going to use a quotient rule to find the derivative. Okay, ready? Low, so low is x squared. Low d high, derivative of the numerator, minus high in parentheses, d low, derivative of x squared, 2x, and then square the denominator. So it was x squared, now it's x to the 4th. Distribute and combine like terms in the numerator. Let's see here, 4x cubed. All right, some people got this wrong on the quiz. When you have a minus here, which you'll always have a minus, you need to distribute this 2x to both terms, but then you also have to distribute the minus sign. So 2x squared times 2x is 4x cubed with a minus sign. Negative 12 times 2x is minus 24, but you have to distribute this minus sign. So negative times a negative is a positive. And what do you notice about the 4x cubes? Cancel. So we get 24x over x to the 4th. And how do we simplify that? So an x cancels out. We have 24 over x to the 4. Okay, how did that start? We multiplied the f times the g, and we had a quotient. So then I wanted to switch up the... What's up? It would be x cubed. Thanks for your help there. I was on to this Quotient quotient rule from here to here, and then distribute the negative, and the 2x was distributed. So, okay. If you look at this, you should be really scared. You should think a product rule with a chain rule. But let's try and use our trick that we used up here. Can this be simplified first before we think about a derivative? So x times, what is g? What do we have to do? We have to take the f function and plug it into the g function. So let's go up here. We have to take f and we're going to plug it into x of the g function. So if this says x squared, what are we going to do with this? Square it. And how do you square a fraction? Top and bottom, right? We're just going to square the top and square the bottom. Let me show that work. And then minus 6 on the end. So we have x times, hold on, 2 over x squared squared minus 6. Huh? What the heck? Maybe I have a highlighter here. The f function has gone in. That's pretty. Yeah, okay. The f is plugged into the g function. G of f of x. Here's our f inside of g. Okay, 2 squared is 4. X squared squared is x to the 4th. All right, what should we do next? Distribute this x. Remember, we're trying to simplify this before we ever take a derivative. So when I distribute this x, I have 4x over x to the 4. Here, 4x over x to the 4 minus 6x. Can this be simplified? To what? Okay. Now, this is easier to take this derivative than it was at the beginning, right? So now we want to take this derivative, but we should rewrite the first term. How do we rewrite this to make it better for the derivative? 4 times x to the negative 3 minus 6. Okay, what is all this? This is x times g of f of x, and we're going to take the derivative of that. What happened to the x? I don't know, this whole Great American Shakeout like shook my... Do you know what's hilarious, you guys? I have the answer key right here. It's like right next to me, but we're a team. Thanks for your help. Derivative of this will be, I'm having a hard time labeling my work. What's the derivative going to be? It's going to be this. I knew the x was going away. Do you know what I mean by the labels? Okay, let's figure out how to make this official. Did I get that right? I did. I checked my answer. Why don't I just say derivative? What if I pointed and wrote derivative? Would that be okay? I don't know, you're the teacher. Okay. We're gonna keep going. How am I doing on time? I'm doing good. Okay, think about that for a minute. I have time. Lots of parentheses. There. Derivative equals that. Okay, this one's silly. This is why I'm doing this whole one with you, because every single one there's a little bit of trick, something weird. If 1 over y equals f of x plus 1, we're going to find dy over dx. What this is saying is take the derivative of y, but this isn't solved for y. But for the last 4 years of your life, you've been solving for y, okay? So we have to get y by itself, or solve for y. It has to say y equals in order for us to take the derivative, okay? So this is 1 over y. Y is trapped in the denominator. How do we get it out of the denominator? Multiply by both sides? Okay. Now y is up top. This y cancels. 1 equals f of x plus 1 times y, but it's not by itself. So what should we do? Divide by this parenthesis thing, f of x plus 1. Okay. So now we have y equals, I just like to move it to the other side, f of x plus 1. Okay, that's our y. We're supposed to take that derivative. Let's substitute in f of x. So 1 over, what is f of x? 2 over x squared plus 1. Okay. Now we have a complex fraction. Okay, do we want to take the derivative the way it is now? No, it's like a quotient rule with a quotient rule inside. So this is why we started the year and we did simplify complex fractions. Took a day or so to do that, or summer school, I don't know. Okay, this is a complex fraction. We need to undo the complexity. So what do we not like about this? We don't like that x squared in the denominator. Do you remember, how do we simplify this whole fraction? Multiply top and bottom by x squared. How did we know how to do that? It was a QR or something. It was a summer school, a summer assignment. So can you simplify complex fractions? That's a yes or no for yourself. Okay. The 2 over x squared times x squared, the x squareds will divide out and we'll be left with a 2. But then we also have to multiply the 1 times the x squared. Okay. So that's that. Now, is that better to take the derivative of? A little easier? Yeah. So. How many times will I say so? Okay, ready? dy over dx will equal, got my labels down this time. What rule are we going to use here? Quotient rule. Here we go. Low d high minus high d low. What's the derivative of 2? 0. Derivative of x squared. 2x. Okay. Oh, hold on. All right, sorry, I'm going to finish this. So we're going to distribute that numerator 2x cubed. It's kind of funny on both of these, the x cubes canceled, yeah. And then don't distribute the denominator, don't FOIL that out, just leave it like that. So final answer. These are great worksheets, but can you guys hear me? I don't like how it's hard for me to show my work in a nice way. It's like ends up, this was my prep work and then here's my derivative here. So it's a little bit messy. Okay, this we haven't quite learned yet, and that's okay. Don't worry, we're going to practice that. So I'm going to switch this out here. So what the heck does this all mean? This is asking for the derivative. All of this means the derivative of whatever was here. So it's the derivative of the f prime evaluated at -2. All of this means the derivative of f prime, which is the second derivative, evaluated at x equals -2. So here's what we do. We write the original function, take the derivative of that, and then take the derivative again. So now here's our second derivative. We didn't have to do anything with this. This means this. Silly, huh? So we took the derivative using the power rule, and then we're going to plug in -2. And that's the final answer there.